Okay, today's recitation is programming. It's a big space and there's many kinds of programming. Rodrigo's going to focus on the most, and the focus is on embedded programming. He's going to focus on the most relevant one, which is in the Arduino environment using the C language. But to a great extent, once you learn one language, you've learned most of other languages. There's some that work very differently, but most of the other ones we use have a very similar programming structure he'll talk about at the end. You won't learn programming in 1 week or one recitation, but the goal of this is just to talk through for beginners the basic structures of a program. So go ahead. Thanks, Rodrigo.
Thank you, Neil. So hi, everyone. Hope you're doing well. I am Rodrigo. I live in Mexico City, and I am in Fab Academy Ciudad de Mexico, which is based at Universidad Anáhuac. And this is my first year as a Fab Academy instructor. I finished Fab Academy last year. And today I will be talking to you about intro to programming. I am not a computer scientist or an engineer. I am an architect, and I've been doing programming and coding since probably 10 years ago when I did my master's degree. I still consider myself a newbie. I still consider myself as learning, but I do want to share with you that the languages that we're using here in Fab Academy is a great way to dive into programming and really just how computers in general work. And it's really just the entryway to a very, very vast world that really is all around us. So I really like programming. I like figuring things out and how things work. And programming gives you that. It gives you the ability to basically have some sort of objective and then have the computer do it. And it's a very special thing once you to figure something out and get your objective done. So anyways, that's just like the basic introduction for the recitation. And we're gonna be looking at what is programming. I'm gonna talk about a little bit about differences in these terms and how programming works in the context of Fab Academy and how we'll be using programs. And then we'll talk about the building blocks of programming, particularly in the languages that most newbies will be using, which is Arduino, which is a dialect or a library for the C programming language, which is a very, very, it's kind of a very old but very common and used across the board in computers everywhere, a programming language, C. So so that's what we'll be doing. And programming is my understanding, or my best definition for that would be, it's a way for us to tell computers what to do. Computers, even though they're great and they can do great, impressive things, in reality, computers are just machines, and they're very fast, but they're also kind of dumb. They cannot understand what you want. They can only understand what you tell them to in very explicit terms. You have to talk computer to make a computer do what you want it to do. So so it's like giving instructions to someone, but you have to be very literal and describe everything in just very precise detail. And the computer cannot understand what you want. It cannot tell, oh, he's saying this, but he really means that, which is very different to the way we talk to each other and the way we talk to our friends or our family. When you tell someone to grab you a piece of paper, they will normally understand that you want something to write on, for example, but a computer will basically crash if you don't tell it exactly what kind of paper and where to get it from and how fast should it give you, et cetera, et cetera, et cetera. You need to give it all the instructions so that there are no kind of there's no room for interpretation. So that's the reason that programming languages were invented, and they have become very easy to use. Back in the day when programming started, people programmed with very complex codes and lots of instructions. And right now we can use language that is very similar to the language that we use in our daily lives, but with some kind of syntax and with some kind of practices, you can really get good at it. And so that's what this lecture is all about. The idea that just what are the basic principles that you can start to use to sort of get your objectives, to just get your objectives done with the technology that you'll be using in Fab Academy. All right, so so coding versus programming. These two words are used interchangeably. Coding versus programming is, people will tell you, I know how to code, and people will not normally tell you, I know how to program. But I just wanted to talk about that because coding is about writing the code, and you can know all the syntax and the rules for the particular computing language that you're using. But programming really is the logic behind the code and how things are structured inside your basically your logic for the program, and so that the computer does what you want it to do. So and then algorithms, those come from math, and those are just, some of them are very, very complex kind of sets of instructions to get a specific result. So I just wanted to talk a little bit about that. What we're learning today in reality is just the basics of coding with some ideas about programming, and in particular, like Neil said, embedded programming. Okay, so so how does a program work? In our context in Fab Academy, we will use programs to tell microcontroller units, the ones that you programmed last week, to deal with inputs, outputs, and talk to other devices. So what that means is that we will load instructions into the little computer chips that you have at home or in your lab, and those will structure the behavior that you want out of your final project or your particular assignment at that point in time. So so that's what we'll be doing. And a program is written in source code, like I said. There are many different programming languages, and there are many also different programming paradigms, which I won't go in detail into, but just know that for now we will be using C programming language, and in particular the Arduino sort of dialect and libraries. Source code is compiled by a compiler into machine code that the chip knows how to execute, and machine code will basically run on the chip, on the computer, on the integrated circuits of the microcontroller unit, to do all kinds of things, either read data from a sensor or tell a motor to move a specific distance or a specific speed, whatever, right? So so really the source code, or the thing that we write on, is really the one that we use. And the reason that it exists is basically because it's easier for us to understand. It doesn't exist just for the sake of the computer. It really exists for the sake of us, so that we can just more easily talk to the computer without having to learn all the codes and all the basically all the functions that the machine code can do. All right. So this is what we're gonna go into. This is what we're gonna go over with some code examples that we have on the presentation. I call these the building blocks of programming, and they are not the only ones, but these are, I think, the most important things that you need to know how to use and how to and what they are in order for you to make effective and efficient programs and efficient ideas, to turn your ideas into code and then then have that code being executed in your MCUs. Okay, so so those are variables, control structures, functions, and methods. I'm going to talk a little bit about debugging and libraries as well, just a little bit. All right, so so variables, these are some of the very kind of, it's like a very basic concept, which is basically just something that points to something that's stored inside the computer. So, so we create it and we give it a name and we store data into it. So there are three basic kind of things that I just wanted to, like, that a variable has in our context, in Arduino, in C. It will have a variable data type, a variable name, and a value. So these three things are what I think can comprise a variable. A data type is whatever the category the variable belongs to. It can be a Boolean. For example, a Boolean is something that's either true or false. It can be an integer, which is this one, and it's something that it's just a countable number, which goes from -1, -2, 0, 1, 2, 3, etc. And then there are also signed and unsigned integers. I'm not going to go into that, but just integers is the general category. And then you have floating point numbers, which are numbers with decimal points. And strings, which are just text variables. So you can create a Boolean for if something is moving, it's true. If something is not moving, it's false, basically. So when you want something that has two states, and when you want to store the information about what particular state that thing has, you will create a Boolean, okay? So for example, in this case, it's moving. When you're gonna have a number that that is sort of to count things, or something that will not necessarily have a decimal point or will not be fractional, you can just use an integer. So for example, my age, I am Rodrigo and I am 37 years old. You could say that I'm 37.3 years old, but normally you say you're 37, right? So for example, if you want to count the number of times that you do something, you will use an integer, because it won't make sense to use a floating point number, because integers are basically used for counting and indexing, right? So so that's integer. Then you have your float, which will be numbers, like I said, that will be decimal or fractional. Those numbers take up more memory. So if you're using them, you're using up more memory in the microcontroller unit. So just use them for things that you need for them to be fractional. If, like I said, my age wouldn't be a very efficient way to save it in a floating point variable. But for example, my speed, if I'm moving, that's something that should be a floating point variable. So anyways, that's something. And then a string data type, that could be my name, that could be a word that you want to store, or a message that you want to convey to, or communicate to something else, either another device or the computer that you're talking to at that particular point in time. So those are just text things, text words in our own language, in human language. So those are strings, and it's they're called strings because they are strings of characters, which is another data type. But these are the ones that I basically use a lot of, that I've used a lot in my programming. So anyways, those are variables. And if there are any questions, please feel free to interrupt me or tell me if something isn't clear, or if I'm going too fast. Just please just let me know, and I'll try to stop for a while and just talk a little bit more about that. Okay, so so I mentioned data types. So data types, what I think are categories that the variables belong to. They are the type of information or the type of things that you are storing, like I said. And we looked at Booleans, either true or false. Characters, which are letters or symbols that are part of the ASCII format or the ASCII standard. Bytes, which are like numbers or values, but basically between 0 and 255, which are eight binary positions. You have integers and shorts. You have unsigned integers, which are basically positive integers, including 0. And floating points. The other one, longs, unsigned longs, unsigned integers, 32T. These are sort of special kinds of numbers that you can use. Some of them, you use them because they are more efficient to use. If you're not, like, if you're still starting and you're not very, you don't know what these are, it's better if you just use normal integers. But as you progress in your skills, you will find that these are more efficient to use because they will use up less memory and be read faster by the machine or whatever. But for now, just these are types of numbers that you will use. Okay. So so these are the data types, and this is a basic example of using variables in the Arduino IDE or the Arduino environment. So, like I said, you will normally sort of declare your data type, which is what we're doing here in each one of these cases. Here I'm creating four variables. And what I'm doing first is I'm declaring the data type that variable will have. It's either an integer, a floating point number, a Boolean, or a string, right? And then what you do is you use these sort of keywords, which are syntax sensitive, which means that if you write them wrong, the computer will not know what you mean, and it'll tell you, I don't understand you. So if you write them wrong, and also bear in mind that these are case sensitive. So like, for example, this string here, you need to write it with a capital letter. But if you write int with a capital letter, you might mean something else. So these are syntax dependent, right? And then you declare, or you basically create the name of the variable. And when you create the name of the variable, you create basically a unique identifier for that variable. And then you have the variable value, which is what the variable actually has inside of it. So if we go back to the sort of analogy that I had here for the variable could be seen like a box that has a type, a name, and it stores a value. And the value is whatever you want to use for that variable. In this case, my age is 37. My speed could be 1.5 meters per second or whatever. That would be too fast for me, but that could be it. if I'm alive or if I'm moving or whatever. That could be true or false. This could also be a 0 or a 1. And a string normally has quotation marks. It's between quotation marks. If I don't put the quotation marks here, the computer will think that Rodrigo is a variable name, and it'll look for it in another part of the program, and it won't find it, and it'll tell you Rodrigo is not defined in this scope, which means that's a name that I don't understand. So when we put quotation marks is when we're using strings. Okay, so just to recap, data type, variable name, variable value. And this equals, this is called an assignment operator. Other programming languages have them. This is called when you are telling the computer that that variable is going to have that value, you assign the value to the variable. You can reassign values. These can change. During my program, I could just reset the value of my age to something else, 38, once my birthday comes up or whatever. So, so just know that this is called assignment in the context of the C programming language. And it means that you're storing this information into this pointer, and this should also be of this category. So I hope that's clear. If it's not, please let me know. So what we're doing here is just basically declaring 4 different variables of 4 different data types. I made all these examples so that you could run them on your MCUs at home. And what, like in Arduino, here we have 2 things that you'll see by default once you start a new program. So, so just for the sake of clarity, I'm going to pull up an Arduino. Screen, and just you've probably done this already, but if you haven't, just go to arduino.cc on a browser, download the software, and you'll have this basically. So once you write a new sketch, it'll open it with this already loaded into it. And this is a text file. This is basically just text where you will write your program. And it has several like default kind of parts, which is the setup, which is everything that's in here, the void setup, and the loop, which is everything that's in here. Okay, so so basically what these are just these are part of the Arduino language. In C, this will be configured by your program, but Arduino already does that for you. And the setup will be things that you will have run once at the start of the program. And the loop is everything that will run continuously while the MCU, while the board is on and it has power. So here you would, for example, put initialize variables, initialize libraries, and do things for the first time, and basically have everything set up so that when this happens, it's just working well. And here you will update variables, update sensor values, read from sensors, and then output things to whatever output device you're using. So that's the anatomy of a basic Arduino sketch. And you'll notice these guys here, these lines that are here, that are grayed out. These are started with a couple of diagonals or slashes. And what these are comments. So what comments are, these are statements or lines that the computer will ignore when it wants to run the program. So whenever you want to write a note or write something that you don't want to be part of your program, you basically started with a double slash. So for example, here in our code example here, I started these with basically just a title and something. This makes the code readable for other people and even yourself. Comments are important for you to understand your own code, or when you will be communicating, you will be documenting your code into your Fab Academy site and your documentation pages. So comments will be very important for you to understand the code that you're writing, but also to communicate and to have other people understand the programs you're writing. Okay. So anyways, that's kind of the anatomy of what we're doing. You can upload these to a commercial board that you want, and it'll basically print whatever's inside these variable, which in this case is my name. And what I'm doing here, it's called concatenating strings. This plus sign is basically gonna put this value, and then it's gonna put this string, and then it's gonna put this value, which I already defined it as this value, okay? So, sorry. So those are using values, variables. Whenever the program or the computer sees the variable name, it'll basically substitute that for the value that the variable has. And you could actually ask the computer to do things that data type cannot do. So just bear in mind, and that could be something where you wanna do something that you would normally do with the string, but you're doing it with an integer and whatever. So you'll get those kinds of errors. So just bear in mind the data types of your variables. Okay, so those are variables. And then we're gonna go into flow control. So flow control is really, these are functions that are used to control how a program gets executed, either in terms of order or in terms of sequence or iteration, okay? So control structures are basically statements or things that you write in your code to manage how things are and make decisions inside the program. And that'll help you create more and more complex programs that can do things several times, check if something is happening or not, or do something in case something else is happening or whatever. You can basically program more complex behavior using these structures. And the ones that we're going to look at here are conditionals, for loops, and while loops. And so let's just look at them. So for example, conditionals, the most common one is the if-else statement. Okay, so if-else statement, you can see them here, and I'm gonna run it so that you can see what's going on. So let me I have here this same program, and I have it configured to upload to the shell RP2040. So I'm gonna upload it, and I'm just gonna show you the output that this program has. So I'm running it. I'm gonna put that over here. So once it's uploaded, it'll talk to the serial monitor, which is what I'm doing here with serial. Every time you see serial, it's basically doing that. So for example, I here put my age, my speed is alive, so the same variables we used. And here, what I'm doing is if my age is less than 37, then it'll print Rodrigo is young, right? And if my age is equal to 37, so basically is equivalent, you'll notice that this is a double equals sign. It's different than the assignment kind of statement that we have here. It's different, right? So it'll write is old, and just so right now, what it's doing here is it's actually outputting Rodrigo is very old, because here I just changed the value, and that's going to happen over here, which is actually every other case here. So just let me go back a little bit. So if this happens, then execute this. And how will it know what to execute? It'll be defined by this curly brackets. So if whatever is inside the parentheses happens, then execute whatever is inside the curly brackets. So basically just if this, then do all of that, right? And that could be, like I'm doing here, just print something to the serial, which will help in communicating with the user. Or it could be reassign a value to a variable, or do something else, or whatever. It could be a bunch of things. But basically, it will do it only if this statement evaluates to true. And what I mean by evaluates to true, it's basically you can read it. Is my age less than 37? Well, it's actually not. So it's not going to do this. And then else, it'll basically, well, what if I want to do something for a condition that's different from this one? Well, if my age is equals to 37, then you're going to do something else, right? And then this is an else if statement. And then the else statement basically does things for whatever other condition. Whatever other thing that it's not this or this will evaluate to, or basically will execute this, okay? So anyways, that's conditionals. You can write them just as a simple if. You can write an if with an else if, or you can write an if with an else. You can do combinations of this, but the basic one is the if statement. And when I say statement, statements are just sort of well, they're not lines of code, but they are just expressions that can stand on their own. So this is a statement, this is a statement, and this is a statement. They are things that have a just discrete kind of code blocks that can be executed by themselves. So as you can see now, these conditionals, these basically help you make decisions in your program. There are other types of conditionals like switch cases, which are very, they are a little bit more complex, and that's the reason that I didn't kind of include them. But if you want to use conditionals and make decisions for many different cases, then you wouldn't use a lot of if statements. You would use switch case statements, but those are different. Anyway, so those are your conditionals. All right, so iteration, for loops. To be honest, this is one of the most difficult things that I had to understand when I learned programming. This is one of the hardest ones because it has several parts to it, and it has several kind of things that you need to understand. So basically, the for loop in this program is here. And it starts here and it ends all the way down here. So in general, the for loop, it'll have sort of the definition of the for loop. And then whatever is inside the curly brackets here, that's going to be executed several times. Okay. So like the if statement, whatever is on the curly brackets is just the code block that gets executed whenever you want it to. Okay. So here, what's in the parentheses, that's the hard thing to understand. And in order to understand it, what we do, well, what I do is first, it basically has 3 parts here, 1, 2, and 3. And it's basically kind of, it's an initial condition, a check condition or a conditional, and then an update statement. So basically initialize, check, update. So what does that mean? So initialize, let me just do something a little bit bigger. Initialize, check, update. These are the 3 things that we will use to control how many times the code block gets executed. So don't mind whatever's inside here for a second, just basically think about this. So in the initialize statement, what we're doing is we're creating a variable that's called weeks, and we're assigning it the value 0. So that's something that we've seen later. It's the same thing that we're doing here, and it's the same thing that we talked about in the other variable example. Then the check is something that the computer will check to either true or false. And if it's true, then the code block will get executed. And remember, the code block is whatever is inside the curly brackets. Okay? And then the update is, once this is executed, what are we going to do with the variable that we created here? So update will create a new condition, a new state is I think a better word. So, and here it helps to do a sort of like a table, right? So for example, let's just initialize. So we have weeks equals 0, right? And then let's do our check. Is weeks less than 15? Well, I would say that's true. So that means that we will execute this code block, right? And in this case, this code block basically just adds 1 to this variable. And this is called plus plus. And it's basically a way of adding 1, like a shortcut to add 1. So whatever assignments done variable value is, it'll add 1 to that. So, and then it'll do serial print, assignments completed, and so it'll do that. And then once it's done executing this, it'll basically update that. And weeks plus plus means weeks plus 1. Weeks plus plus basically means the same as reassign weeks to whatever weeks is plus 1. I hope that's clear enough. But basically, that's what weeks plus plus means. It means reassign the weeks value to whatever weeks is plus 1. So that'll be basically 0 plus 1. So that means that weeks will now be 1, right? So now we have a new state where instead of being 0, it's 1. And we can do a check again. Is weeks less than 15? Well, it is. So let's do it again and whatever. So if I ask you how many times will this be executed, if I was clear enough and if I explained it well enough, you would say that it'll execute 15 times. Because as soon as weeks is equals to 16, this check statement will evaluate to false, and it'll basically not execute this, and it'll do what's called exit the loop. So it'll go to whatever is after the for loop in the program, basically. All right, so I hope that was clear enough. I hope that I explained it well enough. For loops are very important when you want to do things several times, when you want to count things, or when you want to access things that are set up in multiples. So for example, when you have an array, you could iterate through an array, and Python has for loops that actually do that with built-in functions and whatever. But basically, just whenever you want to do something several times, you will probably be using a for loop. All right, so that's it. And be careful, because you could have infinite for loops that if you don't do your checks and your updates properly, it could be that the computer is basically stuck in that loop forever until the memory crashes, until the computer crashes, or until you turn it off. So anyways, that's for loops. Questions about that? Please feel free to let me know. Okay, cool. All right, so while loops. While loops are kind of like for loops. They are similar, but they are different in a very particular kind of way. So again, you have these curly brackets, and again, you have some sort of initialization. You have while, and then parentheses, and the statement, right? So so whenever you have a while loop, you will basically execute this continuously until this is false, right? So basically, in while loops, they are sort of like for loops, but the difference with for loops is that with for loops, you basically have a kind of a predefined number of times that the code block will execute. But with these ones, you're having a code block that's executing continuously, and you normally don't know how many times it will do it. But you do need to have some sort of way to exit the while loop if you want the while loop to end at some point. So for example, what I'm doing here is I'm basically creating a Boolean that's called working, and I'm assigning it to true, which is 1, right? And here I'm saying while working is true. This is what that means. You will do all of this, okay? So you will print, I am working on my Fab Academy project, and I created a tired level variable here. And if I'm working, then I'm getting more tired, right? So let's just add 1 to my tiredness level, right? And if I go up to 15 on that variable, then working will be false, and then I'll print I'm going to sleep. So the next time that it wants to execute the while loop, it'll do this check, but working now is equivalent to 0, so this will be false, and you won't keep on executing that. Let's look at how it works. So I have that here, and I'll upload that to my Xiao. And then I'm going to open the serial monitor, and we'll be able to see what that's doing. Serial monitor. All right, so it's uploading. All right, so it's working. and it'll actually work for, I think, 15 times. And then as soon as it's working for 15 cycles, then it's going to sleep, right? Well, I am going to sleep, right? So if we break this down, so that's what that sketch did. It just output that to the serial monitor. So that's what that sketch did. And again, if we do a table, if we do some sort of analysis, you have working is equals to 1, right? So that's what this is, right? So, and then tired level is equals to 0, right? So on the first pass, on the first time that this is executed, it checks if working is true. It is, so it executes that. And then this tired level, basically it will, it's now 1, because that's what I'm doing here. And then it's checking, is that larger than 15? It isn't, so I won't execute this. And then I'm gonna do everything again. So now I'm checking, am I still working? Well, is this still true? Yes, it's still true. So let's execute that. So tired level will be 2 now. And then it will check this. This is false, so we won't do that, etc., etc., etc. As soon as tired level, it'll do that 15 times, and the 16th tired level will be worth, or its value will be 16, okay? So that means that this will be true, and it'll do this, right? So once that happens, the variable working gets set to false. And this statement will no longer be true. And basically it exits the while loop, right? So, so again, just to recap, a while loop executes the code block until this check statement evaluates as false, or in other words, it executes the code block while the check statement evaluates to true, right? Yeah, so that's kind of the basic idea. All right, so let's go with the next one. Now this is the do while statement. To be honest, I haven't used this quite a lot, but I have it so that not really sure where you would use it right now, but I haven't used it a lot. It's kind of the same as this one. The difference is that the check statement happens after the code block. So what the do while will do, it'll execute this and then perform this check. If it evaluates to true, then it'll go again with this and again check until this statement, whatever's inside here, evaluates to false, right? So it's kind of the same as a while loop. The key difference, or the difference, is that the check statement is done after the code block, after whatever it's doing, right? What this does is basically it executes this at least once because the check happens afterwards. So at least you're doing this once, whereas here, if I set this to false, this won't even be executed even once because this will be false on the get-go, right? So, so anyways, that's kind of what this example is doing. And those are the control, kind of flow control statements or flow control structures that we're using. I'm going to go now to functions and methods, and these are ways of reusing code. Basically, these are things that you write that you're gonna be using several times. So in order to avoid writing them again, you put them into a function, and the function will have a name and a return value, all right? Something that it returns back to you after you call or invoke it. And it's important that the programming languages that we're using, for example, Arduino has built-in functions, and also libraries have built-in functions, right? And custom functions are the ones that you write, or at least that's kind of the distinction that I wanted to make, that there are functions that are part of the libraries that you use. Arduino has its built-in functions, and C has its built-in functions, and the custom functions are the ones that you write. And we're going to look at two examples, one with a return value and some functions that have no return value, but they're still functions. And these are void functions. So we're going to look at an example for those as well. All right, so with a return value, so instead of going through all of this, I'm going to go straight to this. This is a function, and it's basically a way of turning Fahrenheit to Celsius. This is the name of the function. So whenever I use this in my code, it'll basically go down to this and try to do whatever's inside this code block here, inside these curly brackets. Okay, and a function has several parts. So this is the return data type. This is the function name, and this is the function argument. It could be one single argument, or it could be several arguments separated by a comma in the case of C. So again, return data type. Well, let's do something smaller. Return type, that's this float here. So what I'm saying here is that for this function, whatever gets returned will be a floating point number. This is the function name, and this is the function argument. And I'm going to put in parentheses, it could be several of them separated by a comma. Okay, so and then you have a curly bracket, and you do things with the argument, or with it could also be, you could also not have an argument, but you do things, and you have the return statement. So what I'm doing is I'm returning whatever's inside here, this local variable. And I didn't explain that, but this variable name is basically used in the scope of this single function. And it'll return whatever the result of these operations are. So now let's go back to the main code. What I'm doing here is just making a temperature calculator, and I'm asking the user for some input. The user will put a number, and here is where the function is called. This is where it's called calling a function. And you can also look at it as invoked. So when you invoke a function, you need to call it with the right syntax, which is the one you define here. And it'll evaluate this to whatever the result of this is. So let's look at that in action, so let's do, I think it's this one. Yeah, so there it is. So I'm going to upload this to my shell. And then I'm going to open the serial monitor. So now serial monitor. So anyways, it didn't give me that. I think this code is not very good, but let's do Fahrenheit to Celsius. So let's do 32, which I know it's 0. And basically what it did, and then I think this was wrong for some reason, but what it did is basically it got called here and it returned me here this variable, which I'm also creating here. And the return value for this function will be used when it does that. So when I did this, this is actually the result of doing this, but instead of using the value, I used 32, which I know is 0 in Celsius, right? So I hope that's clear. That's a function with a return value. So those are these. And this could be something else. This could be an integer. It could be a string. It could be a floating point. It could be a Boolean. It could be whichever data type that you can use. All right. So now functions without a return value, functions that are called void functions. So these are functions that they normally are used to do things, but you normally don't need a value out of them. You just need them to do something. So for example, here I'm writing this function, and you'll notice that I'm writing it outside of the loop or the setup, because you could want to use them outside of them. You could use this function anywhere in your code. That's the reason you'll write them outside of loop and setup. So this function, this is the return data type, but since I'm not returning any value, I'm using the word void. This is the function name, and this is the argument for this particular function. And whatever is inside the curly brackets for the function is the actual code that the function will execute once it's called. So here I have a for loop that basically takes in this little times variable that I used to blink an LED several times, right? So what I'm doing here is I'm calling the function here with an integer that I'm getting from the user, right? And it'll be, if I type 3, then it'll basically execute this function several times.
Ricardo, time check. This is great. We try to keep these to an hour, which is 2 minutes, so we can go over a bit, but need to go a bit faster.
Yeah. I'm almost done. So yeah, this is the last code example that we were going to look at. And now I'm going to talk a little bit about debugging. Debugging is, you can do it with a debugger, which is basically executing each line of code and looking at what the code is doing at each line. Just a basic kind of tip is to use checks and print statements to know exactly what your code is doing at any time. So, and also use your comments. If your code is crashing and it's not compiling, just try and erase parts of the code to find where the mistake is. And also, you will have syntax errors where you're not using the language correctly. So that's kind of debugging. And then libraries, you will find many different libraries that extend Arduino's capabilities. And I talked a little bit about this. Libraries are collections of code that you can use. And what they do is they basically prevent you, or they save you the time of writing code. They basically give you code that you can use. Tips for writing better programs. Always start with some idea of what you want to do. Never start not knowing what you want to do, because you're probably going to come up with not a very good program. Write pseudocode. Pseudocode means writing in your own words what you want the computer to do. As your skills grow, your pseudocode will look more like code. But for now, just basically do create a variable, do this several times. Those are things that will help you understand what you want to do. Never expect to write a single program from scratch without checking if it compiles. Always write small blocks of code and compile or upload to your board so that you know that that particular block of code that you just wrote runs properly. If you write a lot of code and then you run it, you might have more than one bug. So you want to catch bugs one at a time. You don't want to have several bugs at the same time because it'll make it harder for you to debug. And also read a lot of code. Writing code requires you to understand code. And in order to understand code, you need to read code. So just go on the forums. There are many different forums, Stack Overflow, Arduino forums, and their own Fab Academy repository from other years and from this year. Just learn from your peers and read code because that'll help you understand code. And just also the code examples that we looked at is they are done in C, well, in Arduino, which is a subset of C, and just basic differences between different programming languages. And perhaps Neil here can talk a little bit more clearly about that. C is faster because it's compiled to opcodes in the MCU. Python is interpreted, which means that there's an intermediate step and it makes it slower. And JavaScript is just-in-time compiling. So maybe Neil can just talk a little bit more about that.
Yeah, yes, just to fill in quickly, C is venerable. It used to be all other languages were built on top of it. C gets compiled into instructions the processor understands. Python is a higher level language. It's interpreted, so you don't need to compile it. And it has many things that make it more convenient to program, but all of that makes it slower, and typically by a factor of 100 in looping. However, Python in particular is heavily used now for machine learning. And so there's a lot of work on Python accelerators. And so based on the Python accelerators, you can take plain Python and speed it up, depending on which you use, between 10 to 100 times to catch up to C speed. But that's on top of basic Python. So basic Python is great for things that are convenient and easy to program, but they're slower and they need a bigger processor. C runs down to the tiniest processors. JavaScript, because of its importance in the web, is interpreted, but the interpreter goes through what's called just-in-time compilation, which seems like interpretation, but it's so efficient, it actually writes code that's just as fast as C code. So JavaScript, it has a growing role in application programming, and there are JavaScript interpreters for embedded programming. So I wouldn't look at those languages on the smallest processors we use, but they're beginning to take over for higher level programming in the bigger processors. And also, as you get up to the bigger processors, there's debugging beyond just putting in print statements. All of these chips have debugging interfaces that actually let you reach in, start and stop them, change variables and do things like that. And for example, the new Arduino environment knows how to talk to those. Arnie's asking about C. C and Python. Python is writing little C routines to speed up Python, but it's largely not needed because MicroPython that we use for embedded, or what's called Numba for desktop Python, essentially do the same thing. What they do is take little blocks of code, they add what are called decorators that tell the Python interpreter to pre-compile that. And so that lets you, you can merge C and Python easily, but increasingly you don't need to do it. I like Jim Hart, serial.print, well done, Rodrigo.
Thanks.
Rodrigo, this was great because there's this gap between people who know programming well can't easily explain it. And people who learn it are confused. And you're a great case because you're right at the boundary, having learned it not that long ago, but not being a lifetime computer scientist. So you're a good interpreter.
Thanks.
Okay, we're up to an hour, so I'm going to stop recording.